Good morning. My name is Rishi Tameja. Mm, My section is A2. Today's topic is classical deterministic, classical probabilistic, and quantum probabilistic system with some examples. So now the question is, what is a system? A system is something that takes an input, performs some processing, and gives an output. Different systems behave differently depending on the rules they follow. Classical deterministic system. A classical deterministic system is a system in which the same input always produces the same output. There is no randomness. The behavior is completely predictable. Some examples of classical deterministic systems are like logic gate and or not, like calculator operations 2 plus 2 equal to 4 always, that is fixed program traffic signals, and like simple classical algorithms. Why it is deterministic? Because the output is fully determined by the rules. There is 100% certainty. You can predict the exact result every time. Example f of x equals to x plus 3, input equal to 5, output equal to 8 always. So the classical probabilistic system. A classical probabilistic system is a system where the output is not fixed. Output depends on probability. Exact result cannot be predicted, but probability can be predicted. Some examples of classical probabilistic systems are coin toss, like head 0.5 it has probability, tail has 0.5 probability, like rolling a die, weather prediction, and randomized computer algorithms. So why it is probabilistic? Because such systems include randomness. Output is one of many possible outcomes. Each outcome has a certain probability. Like for example, rolling a die has one has a probability of 1 by 6, two has a probability of 2 by 6. For example, tossing a coin, head has a probability of 1 by 2 and tail has a probability of 1 by 2. That it's. And third type of system is quantum probabilistic system. In quantum systems, a particle or qubit can exist in a superposition of states. State can be written as phi equals to alpha 0 state plus beta 1 state. Measurement collapses the state into 0 or 1. Probabilities are p of 0 equals to alpha mod of alpha square and p of 1 can be equal to mod of beta square. Key features of quantum probability are superposition. System can be in multiple states at the same time. Probability amplitudes. Alpha and beta are complex numbers. Measurement collapses superposition to a definite state. Probabilities come from squared magnitudes of amplitudes. Some examples of quantum probabilistic systems like qubit in superposition, Hadamard gate creating equal probability state, like 0 state goes to in 0 state plus 1 state divided by root 2. Some other examples are like Stern-Gerlach experiment, spin up or spin down. And other quantum probabilistic systems are also there, like for example CC naught gate in which and other C naught gate in which target qubit is there. If it is 1, then the control qubit is flipped to another system. Let's compare the classical deterministic, classical probabilistic, and quantum probabilistic systems. For output type, classical deterministic is fixed because there is 100% certainty, and in classical probabilistic, it is based on the probability. Yes, of course. And for output type in quantum probabilistic, it is based on the quantum amplitudes. Like example C naught and CC naught. Already said in C naught like control target control qubit should be 0 so that the target qubit can be flipped. Control qubit should be 1 so that the target qubit can be flipped. And in like classical deterministic state is single defined state, and in classical probabilistic state is probability distributed. In quantum probabilistic system, the system is superposition state. In classical deterministic, there is no randomness. In classical probabilistic, there is randomness, yes, and in quantum probabilistic, there is randomness and also is there superposition state. For example, in classical deterministic, AND gate is there, and in, for example, in classical probabilistic, example is coin toss, and for example, quantum probabilistic, the example can be qubit or Hadamard gate. So, and the conclusion is deterministic systems are fully predictable. Probabilistic systems include classical randomness. Quantum probabilistic systems involve superposition and measurement. Quantum systems are fundamentally different from classical ones. Thank you.